Welcome to the first episode of NCERT Beyond the Lines. In this episode, we will take one paragraph of NCERT having 3-4 lines and we will deep dive and explore the hidden meaning of that line. The topic I have chosen today is from the chapter Photosynthesis in Higher Plant. The name of the topic is Chemiosmotic Hypothesis. The line I am quoting is from page number 141. The topic chemiosmosis has 3 points, first, second, third. The second point, that is on page number 141, it says, as electrons move through the photosystems, protons are transported across the membrane. Stop. This happens because the primary acceptor of electron located on the outer side of the membrane transfers its electron not to an electron carrier but to an H carrier. Stop. Hence, this molecule removes the proton from the stroma while transporting an electron. When this molecule passes on its electron to the electron carrier located on the inner side of the membrane, a proton is transported into the inner side or lumen side of the membrane. Now this entire point, you can see there are 4 statements. So for understanding this, you need to have a basic idea of what chemiosmosis is. That process of photosynthesis is divided into 2 parts, light reaction and dark reaction. Chemiosmosis actually explains the mechanism of light reaction. Now here the NCERT here usually deals with the non-cyclic ETS part, that is the non-cyclic photophosphorylation part. Now say this thing is a thylakoid. This one is a thylakoid. Very often I see students confuse it that thylakoid has double membrane because the diagram of NCERT seems like it has 2 membranes. No, thylakoid actually has single membrane. So why there are 2 lines in that NCERT diagram? This is simply because this part explains the thickness. This thing what you see, there are not 2 membranes. This explains the thickness of one membrane. Right? So when I say this part, say if I want to denote this part, this is not the outer membrane, rather this is the outer side of the membrane. This thing, this is not the inner membrane, this is the inner side of this membrane. Now let's move to the topic. See here, there is a photosystem called PS2. Definitely you know about photosystem 2 if you have read this chapter. So in photosystem 2 we see there is a chlorophyll A in the reaction center which is P680, and this is definitely photosystem 2. When sunlight falls on this, electrons are excited, move to an excited state, and they are moved to the first electron acceptor. And in non-cyclic ETS, that is in photosystem 2, the first electron acceptor is pheophytin. Now look carefully where I have drawn pheophytin. This pheophytin is on the outer side of the membrane. This is the inner side and that one is the outer side. So this pheophytin is definitely located on the outer side of the membrane. If I say inner side of the membrane, it should be present somewhere around here. Now this pheophytin transfers its electron to someone called plastoquinone, PQ. So this thing here, this carrier here is called plastoquinone. Now this plastoquinone itself receives a proton from the stroma. Say this is proton. It receives proton from the stroma. Now sometimes we often confuse the statement as NCERT writes receives a proton from the stroma. Now here a proton is dependent on number of electrons. For 1 electron there is 1 proton. Since we have taken 2 electron, I have written 2H plus. Now this PQ, when it receives 2 electron and 2 proton, it gets converted into PQH2. Now remember, the name of PQ is plastoquinone and the name of PQH2 is plastoquinol. Now why that name came? Because ketone when reduced becomes alcohol. So PQ to PQH2 means reduction, addition of hydrogen. So the earlier one is called plastoquinone and the later one is called plastoquinol because of the addition of hydrogen or the reduction reaction. Now this PQ here, it is an electron carrier as well as a hydrogen carrier. But then the electron is transferred to someone called cytochrome B6F. Now this is itself a transmembrane acceptor. Transmembrane means it moves across the entire membrane. Now in non-cyclic ETS, remember, only cytochrome F is functional. Cytochrome B6 is non-functional in this process. Although the name of that entire complex is B6F, but I repeat it again, cytochrome B6 here is not functional. The electron will move from PQH2 to cytochrome F only. Remember, cytochrome B6 is functional only during cyclic ETS. Here we are studying non-cyclic, and in non-cyclic the name of complex remains same, cytochrome B6F. B6 is located on outer side of the membrane, F is located on inner side of the membrane. Here only F is functional. Now the problem here is that cytochrome F, it receives the electron because it is an electron acceptor, but PQH2 also has 2 protons, so these protons have to be pumped on the inner side or the lumen side of the membrane. Now read this statement from the beginning. As say somewhere here is the photosystem 1. Although there is plastocyanin up here, I am not drawing it because for explaining this particular statement we don't need plastocyanin thing. Say this is PS2. As electrons moves through the photosystem, that is from from PS2 to PS1, protons are transported across the membrane. That is, this electron, as it moves from here to right up here across the photosystem, protons are transported, see, from PQH2 to here across the membrane. Stop. This happens because the primary acceptor of electron, that is pheophytin, located on the outer side of the membrane. See the location of pheophytin, it is on the outer side, transfers its electron not to an electron carrier but to an AH carrier. Here PQ, besides being an electron carrier, it is also an hydrogen carrier. Don't confuse it that it is not an electron carrier as NCERT says it. The statement could have been more beautifully framed as the primary acceptor of electron transfers its electron not only to an electron carrier but also to an H carrier. Now the next line says this molecule, means PQ, here this means PQ, removes a proton from the stroma, while transporting electron. It means when PQ transfers its electron, it removes a proton from the stroma, right? Now the next line says when this molecule, that is PQH2, transfers an electron to an electron carrier, the next electron carrier is cytochrome F, right, which is located on the inner side. Now see how technically NCERT has changed this statement. They have not directly said that cytochrome B6 is not involved. They indirectly said it because they said this molecule, that is PQH2, transfers its electron to a carrier located on the inner side of the membrane, that is cytochrome F. That is, from PQ, electron moves to cytochrome F. And during this process, this proton, that is 2H plus, moves from PQH2, but cytochrome F will not receive proton. It will receive electron, but it will not receive the proton. So the proton is transported into the inner side or the lumen side, and this is called proton pump. I very often say that some students read that here is an F0 F1 particle, this is the proton pump. No, say this thing right here, that F0 F1 particle from here H plus 3H plus moves to give 1 ATP. This is not proton pump, this is facilitated diffusion. Protons moves from its higher concentration to lower concentration. Pump is a word that you use for active transport. For the movement of this 2H plus to the inner side, you need energy, and this energy is carried out by the redox reaction. Now where is a redox reaction? See, there is an electron. If electron moves from say A to B, someone has lost electron, someone has gained electron, that means it is a redox reaction which will give energy, and using this energy, this H plus will move into the membrane, into the inner side of this membrane. So this was the exact meaning of this line. So if I explain this thing again, I will say that remember it like this. This thing here is a thylakoid. Say this one is a thylakoid, and remember thylakoid has single membrane, and the entire part here represents the thickness, The first electron acceptor here is pheophytin. The excited electron from PS2 moves to pheophytin. From pheophytin, we know it moves to PQ, that is plastoquinone. From PQ, it moves to PQH2 by receiving 2H plus. And where from this 2H plus will come? This 2H plus will come from stroma. Now, receiving 2H plus, PQ becomes PQH2, that is plastoquinone becomes plastoquinol. And from here it goes to somewhere. This electron moves to somewhere called cytochrome B6F. This is cytochrome B6 and here is cytochrome F. And if they ask about the specific location, always say that it moves to cytochrome F and not B6. If they ask the name of the complex, definitely you will say B6F. But if you have an option to choose between B6 and F, then you will choose cytochrome F, because NCERT clearly states in the inner side of the membrane in the last line. And since this molecule is an electron, this molecule, that is cytochrome F, it is definitely an electron acceptor but not a proton carrier. So PQH2 has to pump this proton into the inner side or lumen side of the membrane. I hope this was a very good explanation for a student's perspective, for a student's point of view. See, this hidden lines of NCERT has to be asserted in such a way that you understand the meaning of every line of NCERT. It is not like that you will read NCERT 4 to 5 times and you will go for NEET and you will clear it. You have to interrogate NCERT other than just reading these lines. Interrogate this NCERT, make statements by yourself, look properly into the words like only, always, never, few. These words are also very important. You must be familiar with these words while solving statement based questions or assertion reason questions. So in this series or these episodes of NCERT Beyond the Lines, I will catch up some more important topics like this, which will rather boost in your preparation. That is, you need that. Remember one thing, 355 is not equal to 360 in NEET biology. So this small simple variations changes the game entirely. So I hope this explanation was useful and we'll see you very soon in the upcoming session.